Okay, so if we kick off, for those who don't know me, my name's Greg Kingsley. I'm the product manager here at Ness Corporation. We've been dealing with the M1 in various forms. It has expanded over the years, but the M1 is a very solid platform. It's been out for many years. It's virtually bulletproof. We have a little slogan with the M1, if you can dream it, M1 can do it. And hopefully we'll be able to demonstrate that to you today and show you just really how easy it is for you to be able to program the system to operate how you wish to operate and to do the features that you want it to be able to do. The M1 is more than just a residential panel, which is very strong in residential and security and automation, but it's been used in a lot of different applications, around the world, from residential, commercial, fitness centres, education, shops, you name it. M1 can be used with it, with a lot of different add-ons, whether it be voice control, whether it be interface into CCTV systems, that anything can occur on an M1 can happen on a CCTV system or on the NX Witness, including video verification and so on, so on. The M1 itself comes at the top left-hand side in this clamshell. It comes with 16 zones on board and can be expanded up to 208 zones. It is a hybrid system, so we can add wireless receivers onto the system. So out of that 208 zones, 144 zones can be wireless, or you can mix and match. So, for example, if you only wanted to have, perhaps 4 zones of wireless, then you can have 204 zones of hardwired to make a maximum of 208 zones. The system has 13 outputs on board. So obviously you've got your internal siren, your outside siren, your strobe, and you've got 10 other outputs on board, but it can be expanded up to 205 outputs by putting output expanders on. The system can support up to 199 users. It can be split into 8 areas, so you can have the house, garage, warehouse, storeroom, sales office, manufacturing plant, or whatever you want, broken into various areas. There's 6 arming levels, which we'll cover a little bit more details shortly, but the 6 arming station, you can arm it in away, home, vacation, etc. And as I said, we'll cover that a little bit more later. There's a lot of other functions that can have. It's an optional 2-way listen in for alarm verification. So if alarm goes in, you can listen in to the microphones installed on site, hear what's going on. Obviously, you've got video verification from maps or whatever you can go into. There's also a built-in astronomic clock, so the system knows where the system's been installed. So if you want to turn, for example, lights on in a car park, you can turn it on when it gets dark rather than a set time, because a set time doesn't work from winter to summer. You don't want to turn the lights on, for example, at 6 o'clock in the middle of summer. The customer will think it's turning on in the middle of the day, where if you're turning on it's 8 or 9 o'clock at night in winter, it's too late. So with the astronomic clock, it knows exactly where the panel is installed, and you know when sunrise and sunset is for that location. So then you can say whenever it's at sunset or period before or after sunset, turn the light on and off, or do whatever you want it to do at that particular time. The M1 itself, obviously we sell it as a clamshell only or as a panel only, but we sell it as a kit in 3 different forms. We sell it in a 14-inch housing, a 28-inch housing, and now we've introduced a new one in a 14-inch housing, which we call 2-way wireless ready. It comes, it's only additional $25 or thereabouts, and the radio receiver built in. So with the radio receiver in the kit, the 2-way wireless radio receiver kit, it's a great cost saving. And then you just have to buy the peripheral radio devices that you want to go onto it. So if you're going to put radio on, it's the way to buy the kit. All kits come complete with obviously the board, the housing, backup battery, power supply, tamper switch, etc. So it all comes. All you have to really then is select what keypad you want, what detection devices you want, and sirens, etc. There's 3 main keypads sold as options for the system. We've got on the left-hand side here the LCD keypad, 16-character LCD display. There's also the touchscreen, the 3.5-inch touchscreen navigator keypad. And there's also the arming station. The arming station is great if you want to put into perhaps a storeroom or garage where you don't want the full display of knowing what zones or be able to program it from the keypad, etc. All you want to do is to know if that area is armed or disarmed, to be able to arm and disarm it. Also has 6 function buttons, which we'll cover the function buttons shortly. But 6 function buttons, so it's a great little low-cost alternative for the areas where you just want to arm and disarm that area rather than putting the main keypad in the system. You can mix and match these keypads on the one system, so you can have some LCD, some navigator, touchscreen, some arming stations, all on the one system, up to 16 keypads on the system. Some of the functions or the features of the keypad themselves and some of the differences between the two is that on the Navigator and KP2, there is an input and an output hardwired into those keypads if you wish to, where it's not available on the arming station. Now, a great advantage of that is that you may want to wire a zone from the front door, for example, straight into the keypad. You want to lock output, take the lock output out of the keypad rather than home running it all the way back to the panel. So you can do that straight in and out of the keypad. The KP2 keypad also has an optional external 26-bit WearGAN, so you can hardwire a card reader directly into the back of the KP2 keypad. So again, if you've got the keypad at the front door, you can hardwire the 26-bit WearGAN straight into that keypad and then still have your front door read switch at that keypad and the lock output, again, without having to hardwire back. It's only that keypad that has the WearGAN. The Navigator and the arming station don't, so you'd have to wire if you want to put a prox readers onto the system, you wire them back into a single door access module. Function buttons on the Navigator keypad, there is 6 function buttons and 6 on the arming station, and on the LCD keypad there's 4 function buttons. We can see the 4 function buttons down the bottom row of the keypad. And a function button as default out of the factory is set, for example, police, fire, medical, but they can be programmed to whatever you want. They might be programmed to turn a light on and off, to unlock a front gate, to open and shut the roller door, to arm a different area, or whatever you want to use them. You're fully programmable of what you want to use them for. So then the main functions between, or features, difference between the various keypads, apart from obviously the looks. KP2 has the LCD backlit, where the Navigator's a touchscreen. And when we look later for programming, it's a lot easier to program and for the customer to operate with a Navigator touchscreen, is because they're looking at one page of options at a time rather than just one option at a time. And you use the Navigator keypads to go the next option, next option, next option. The Navigator's got a full page of them at a time. The siren outputs out of the system, if we first of all look at the outside siren can be as default out of the factory. It's got just put an 8-ohm horn speaker. It's got a siren driver built in. But with the outside siren output, which is output 2, and we'll have a look at this shortly, is that it's programmable to be either a siren output or 12-volt output. So if you're going to connect it to, say, a combo siren that just needs 12 volts, you can program that output to be a 12-volt siren output. If you want to put a high-security satellite siren on, it only needs to be, only needs to be a siren output. A 12-volt output where you've got the siren output. The inside sirens should really be a 8-ohm horn speaker. The reason for that is that's where the voice comes out of the system as well. So we get the voice out of the internal siren where it says system armed, system disarmed, gives the customer some guidance. The back door is open when they're trying to arm, etc. All that voice comes out of the internal speakers or the inside speakers. So if you were to put a 12-volt top hat screamer, for example, then sure, it will activate when there's an alarm, but no voice will come out. So that's where we recommend to use an 8-ohm horn speaker. Of course, you could use an 8-ohm horn speaker like the outside siren, but it does sound a little bit tinny. So if you use, for example, our Eco speaker, then that gives a nice bass sound, and it is paintable. So you could put that cover directly up, or alternatively, when you put it up, you could paint that the same colour as the wall so it blends in, or the ceiling, depends where you want to mount it. There's also an optional plug-in Ethernet module. So if you're going to connect to program it, perhaps via the Ethernet, either local or remote, if you want to get email notification, it can connect to a time server. If you want to then connect to an app, of course, you need to then put it to the Ethernet module to be able to get it on the outside world, etc. So that's an optional Ethernet module that plugs in. And in regards to apps, there's really three main apps that are available: the M1 Cloud, the M1 Touch Pro, and the eKeypad. Effectively, the M1 Touch Pro and eKeypad are becoming obsolete now because the new Cloud app, which there's no port forwarding required, etc., you get true push notifications. As shown on the left-hand side there, you've got your push notification. You've got full control of the system, both security and automation. You can turn lights on and off, outputs on and off, run tasks, do whatever you want via the cloud, etc. And also you're just paying a monthly fee rather than paying $60 out, or for an iOS version, $170 plus for the app. So for the cloud, you're just running a small little service, a monthly service fee for the cloud. We'll have a look at modules that can go onto the bus, but effectively all the modules you want to put in, input, output expanders, wireless receivers, single door access modules, sit on the data bus. And we're going to cover this, as I said, in more detail shortly. All the modules should be home run. Should be daisy chained in and out. But if you want a home run, we do have data bus hubs, and we'll have a look at that shortly on the system. In regards to the radio receiver, just down there, so when we put a radio receiver, we can actually put 4 transceivers or 4 radio receivers on the system. So if you've got a large facility that you want to be able to cover, in this example, if it's a commercial premises, shipping, warehouse, production, sales office, etc., you can put a transceiver or receiver in each one of those areas and give you a total coverage. A lot larger coverage than what you would be able to if you can only put one receiver on there. With the two-way wireless, one of the things that make it totally reliable and security sense and long life for the battery, low power consumption, is that when a device transmits, it then gets a signal back from the transmitter or back from the receiver to say, I've got your signal, stop sending it to me. So it only sends a signal once or twice instead of about 25 times at full power. So when it gets the reed switch sends a signal, transceiver says, yep, thanks, I've got that, and sends it back so the transmitter knows not to stop transmitting. So when the LED comes on the two-way, it comes on when it gets a signal back from the transceiver. So you know exactly when it is. Also, when you're in walk test and you've got the wireless PIR, the Lux wireless PIR, when you walk in front of it, the bright light will come on. The high intensity LED comes on when the customer's doing a walk test, so they know that, again, it's got the receiver has given the signal back to the transmitter to put that night light on. So it makes it a lot easier to know when it's been detected when you're doing a walk test on the system. With the radio key, the same. The LED comes on, lights up either red or green. So when I arm the system, the LED will come up red. When we disarm with a radio key, it comes up green. So straight away, you don't have to now chirp the sirens outside and wake all the neighbours up when you're arming and disarming to know if it's armed or disarmed. You can see the LED on the keypad, on the radio key, to know if it's been armed or disarmed. If you're driving up or you come home and you want to know, is the system armed or disarmed, then you just hit the information button, the button there. When you push that, again, if it lights up red, you know the system's armed. If it lights up green, you know it's disarmed. If it lights up red and it's flashing, then you know it's armed, but we're in alarm, like the strobe would be flashing. So it's flashing to say, yes, I'm armed, but I've got an alarm. Be cautious, since you've been out, there's been an alarm activated. What we find is a lot of people will get these radio keys, for example, or radio reed switches, and they push the button and no light comes on. They think the battery's flat, and the reason the light's not coming on is because the light only comes on when it gets a signal back from the transceiver. So just something to watch is that when you get the radio key and you're pushing the buttons, if the light doesn't come on, of course, because it's not learnt into the receiver to get the signal back from there. So just to be aware of that on the two-way. To add more hardwired zones onto the system, we've got the zone expander here. So with the zone expander, it sits on the 4-wire data bus, and there's 16 hardwired inputs. And you can put up to an additional 12 expanders on the system. 12 times 16 plus the one that's on the main board equals 208 zones. So nice and simple, just put that on the bus and there's another 16 zones. Add another one, another 16 zones, etc. to expand up. With the output expanders, there's two different type of modules that can provide an output expander. The first one on the right-hand side here is the M1 RB, M1 radio or relay board, I should say. It just sits on a ribbon cable, so you plug it into the main board on the ribbon cable and gives you 8 relay outputs. The second one sits on the data bus, so we'll see the little data bus blue connector down the bottom right-hand corner here. Data bus comes in here, and it gives us 8 relay outputs. Now, that's a 16-zone output expander. We've got 8 relays and 8 voltage outputs. If I add then this relay board, plug the ribbon cable straight into that expander, not the main board, it gives me 8 relay plus another 8 is your 16 relay outputs. Okay, so it's a 16 output expander that sits on the data bus, 8 relays and then 8 voltage, but plug that relay board in, now gives you 8 plus 8, 16 relay outputs. So you can use that for controlling anything, garage door, lights, pumps, sprinklers, fans, you know, you name it, it can be used for effectively anything. For access control, the system can handle up to 16 access control doors, 199 users, and it connects via, it can have a card reader going straight into the KP2 keypad, or alternatively, you can then have a single door access module that you put the card reader into. Now, if you want more advanced functions of knowing who went through what doors at what time and software for the end users, etc., then we advise to recommend to put it into a more dedicated access control system. And we have 2 main access control systems that we've got there, being the Hike Vision 4-door access control or the Verdi MCP 4-door. And what that does is we have a high-level interface into the M1. So you badge the card in 3 times on the access controller to arm the system. 1 card will then disarm the system. And when you've got the system armed or disarmed, it can deny you access while the system is in the arm state. So if people aren't authorised to be able to arm or disarm the M1, we can deny them access through the door. So they're not coming through the front door at 9 o'clock, which they're authorised to do, but the alarm system's still on and cause false alarms. So the system can still deny you access while the alarm system's on. Someone who's got permission to be able to then badge a card to then disarm the alarm system will then enable the other users. So that's what's available both with the Hike Vision 2 and 4-door access controllers and the Verdi, if you want more than typical 16 doors, more than 199 users, etc. The single door access module, which is this unit here, it sits on the 4-wire data bus, again down here, and then you've got the WearGAN input for your card reader. It's got the relay output for your lock. It's got a zone input, request to exit input. It's got adjustable times up here that by the links there that you can set for how long a door open, too long, door held open, etc. on the system. And if you want to put 5, 6, 7 doors on the system, you just buy another single door access module. So it makes it nice and easy. Just run a Cat5 cable, put the single door access module perhaps above the door on the secure side. Again, you don't have to necessarily hardwire the card reader and everything back to the main panel. But you'll probably find that by the time you buy 4 single door access module, it's probably cheaper to buy a 4-door say, Hikvision access controller, and then just have the interface into the M1 doing it that way. So there's a couple of different options that you can do depending if it's commercial, residential, what the application is you're using it for. Other things that we can integrate into the M1 is basically anything electrical. So whether it be lighting control systems, as I mentioned, access control, thermostats, sprinklers, covering anything electrical can do it. And it can be done either on a high level or low level. So obviously a sprinkler system just needs to have a voltage. A door strike just needs to have a voltage, for example. So you can do that via the low level. We also have a lot of high level interface to various things. So whether it be sitting on the data bus, so whether it be a Lutron, whether it be UPB, Instant, whether it be the communicating thermostats to control things like carrier air conditionings, Daikin, Mitsubishi, Toshiba, etc., can all sit on the data bus, and we have a serial expander. And that serial expander, what it does, it has links on there, and when you change those links, it will then set the protocols up for what you want to communicate to. Okay, so we can either do communication or high-level interface via the serial port expander that allows you to add, it's got one RS-232 port on the main M1 board, but it allows you to put another 8 RS-232 ports, another 8 485 ports, etc., for high-level interfaces into various things. So if you want to interface into UPB, for example, that plugs into the serial port expander. You set the links for UPB, so effectively comes in here, serial expander, and then goes out to UPB. If you wanted to go to the Coolmaster to interface to Daikin, Mitsubishi, etc., you set the links up for that, and it will then set it up accordingly from there. A lot of other high-level interfaces that we've got. This is, again, it's just a small example of what we've got high-level interfaces for, whether it be the CBus Clipsal, which sits on directly onto the Cat5 data bus of CBus, so you don't need a PSI or CNI. Control 4, we sit that interfaces via the Ethernet module. Advantage Air, as I said, Daikin, Crestron, AMX, virtually you name, a lot of those functions have got it. And if not, there's more and more getting added all the time. But all the main ones, Control 4, KNX, CBus, Crestron, AMX, we've got it covered. We've also got a voice interface. So with the Ness automation bridge, nice little plug-and-play device is that will interface into any of your smart speakers, whether it be the Google, Amazon, Alexa, Siri, etc. It will talk to all the main three ones there, even an iWatch, etc. So you've got full control from via your voice. So if you want to say open the garage door, turn the sprinklers on, do this or do that, arm the system if you wanted to, it's fully programmable. So you can be lying in bed and tell it to turn the lamp on. Don't even have to stick your nose out of the bed. Just do it all from voice, etc. There's also water sensors. So one of the biggest damages in a house is when a water pipe bursts, washing machine overflows, the incoming hose from a washing machine, dishwasher, etc. bursts, etc. So you can put the water sensor directly behind those devices, and when they detect, we can then activate a water shutoff valve that electrically shuts the incoming water off to a premises. The customer then comes home, sees that they've had water damage. There's only a little puddle behind there. They can fix the hose, do what they need to do, hit a button on the keypad, and bang, they've got water connected again. So it saves a lot from there. If you want to switch something higher voltage than your normal 12 volts that you would with the M1 relay, is that we sell the little Omron relay that can switch 240 volts right up to your solid state relay that can switch 240 volt 40 amps. So you can switch your 12 volt input straight from an M1, and then you've got your high current load on the outside. So if you want to turn on and off water heaters, pumps, high voltage lights, etc., motors, you can do that via one of those devices. And one of the last modules we can put on there is also the temperature probes. We can put up to 16 temperature probes, and they're great for putting it into food storage areas, freezers, computer rooms to know if, or server room to know if the air conditioning has, gone bust or something like that. So you will know that it'll give you an alert that the temperature's gone up or below a certain thing. You know what the temperature in your pool or your spa is, etc. One thing to watch is the temperature sensors must connect to one of the first 16 zones on the panel. You can't put a temperature sensor connected to one of the remote zones on the data bus. It's got to be the main zones, the first 16 zones on the panel. And if you want more power out of the M1 was capable of driving 1.5 amps out of the system. We recommend once you get above 1 amp, 1.1 amps, to add an external power supply. We recommend something like our PW315. It's a 12-volt, 5-amp power supply, and with the backup battery all included. And then you've got the area up the top of the power supply to put some expansion modules. So whether it be an input expander, an output expander, or via that little metal bracket there, that screws on the back of the housing, and that allows you to put 2 modules in here. So on that one power supply, you can put, for example, 2 zone expanders, 32 zones, an input and output expander, so 16 inputs, 16 outputs on that one little panel, and all you need to do is run a Cat5 cable from the main panel to this one, to the next one, to the next one, to give you power for all those modules, rather than getting home running everything back to the panel. So if you had a large commercial premises, a factory, warehouse, etc., and you've got zones in all the factories or the warehouse, you don't have to then home run it back to the panel. Just put a little satellite module in here, 16 input, 16 output, for example, if you want to put in there, and just run a Cat5 cable from the panel. It's a lot cheaper than home running all the cables and everything and the labour back to the main panel. And just on that, there's other expansion modules that we've covered the little 2-tier module down the bottom. We sell the enclosures separate, the 14-inch and the 28-inch. There's a battery shelf, so if you've got a 14-inch, the battery can sit on the bottom nicely. The 28-inch, you may not want to run the cable down to the battery in the bottom, so you can put a battery shelf to put the main panel up there, battery here, and leave all the bottom area clean for extra zone expanders, etc. When you mount the panel into the housing, as you can see there, the M1 clamshell sits on there. There's 2 screws that you mount in the back of the housing, and then without even taking the clamshell, the board out of the clamshell, that will then clip onto the board, slits on there nicely, couple of locking screws at the bottom, and your panel's mounted. You can mount the Ethernet module up the top right, a zone expander or an output expander on the left, battery down the bottom, and if you want to, you can also put a data bus hub, which we're going to cover in a moment. One little trap for young players is if you're going to put an output or an input expander in a 14-inch housing, as you can see there, they all come with a circuit board guide, so it stands them up so you're using less room in there. Don't mount the input or output expander on the right-hand side, because that's showing an Ethernet module, which is only half size. If you put a zone expander, it goes down to, say, that area there on the right-hand side, and when you put the lid on, the cam lock is going to knock on that board and you won't be able to lock it. So then you think, oh, so now I've got to take that board off and put on the left-hand side, which is not a problem because the cam lock's not going to hit it. So just be aware the cam lock on the right-hand side there is, don't put an expander down that side. When you put it in a 28-inch housing, so here's an example now, is that we have the M1 up here, Ethernet module up here, data bus hub, we've got the battery sitting on a battery shelf, we've got some zone expanders and output expanders laying down on the board, which you can do, or via the circuit board guides that come with them. Whoops, sorry about that. If we hit the right button, is that the circuit boards, they can stand up in that area there, so it makes a lot more room to be able to put a lot more modules in there. You can effectively put 4, 8, 16, 20 odd modules in the system. So just before we go on to the next section, any questions that come in? I can see we've got one here. Can we get announcements from the M1 to the Google speakers? Yes, you can. So you can program the automation bridge is to say whatever you want. So you to hype in what you want, and then when an event occurs on the M1, you can get it to speak through the Google speakers. At the moment, it only works with the Google home speakers or the Google speakers. It doesn't work with Alexa, but there might be some development on that shortly. But yeah, definitely with the Google speakers, you can get it to talk. So when the perhaps garage door opens, system arm disarmed, or whatever you want to do, it can come out of the Google speakers as well. Can readers be wired into the bus? Card readers need to be wired into the single door access module. So you hardwire the card readers into the single door access module, and the single door access module will then sit on the data bus. So I guess it may or may not answer your question. The card reader itself can't sit on the bus, but when you're wired into the access control module, the access control module is sitting on the bus. So in that way you can, yes, but you can't get a 485 card reader and sit on the M1 485 data bus, because all the 485 data bus, it's 128-bit encrypted. We're talking about security. So a normal RS485 reader doesn't have that sort of encryption that the M1 handles. And if it did, then it's really a security breach on that 485, because of everyone will know the protocols, etc. So yeah, that's how you connect the card readers to it. And it also has to be 26-bit WeGAN. So you could even do face recognition with getting more and more people that I've heard of recent times with the cost of biometrics getting a lot lower, and people don't want to touch fingerprint readers, etc. now with the COVID, etc. So you can then put a face recognition unit on the system, have the data bus, have the WeGAN go into the module on the data bus, and then you just walk up to the keypad or walk up to wherever you want to do, picks your face up, and then can arm the system, disarm the system, or whatever you wish to do. All right, if there's no questions, we'll continue on here and look at the hardware overview. So the first section was just to give you a brief or overview of what the M1's all about. If we now look at the M1 in particular itself, we'll move on and do this. But just on this slide here, the thing of note is right down the very bottom is the sticker that's on the panel is the serial number. Whenever you're connecting with this programming software to program the system, you need to know the serial number. The serial number is in 3 or 4 different places. The serial number is the easiest way to find. It's on that sticker on the bottom of the clamshell. If you did take the cover off the clamshell, it's also on the circuit board. It's when you first power the keypad up, it will flash the serial number, and once you go into programming, it's in the programming there as well. So, but the easiest place to find it is the sticker on itself down the bottom, and we'll cover those other terminal blocks on the next slides. Starting off, first of all, up the top left-hand side of the clamshell is our 16 hardwired inputs. And those hardwired inputs right across all 208 inputs are programmed on a zone-by-zone basis. So they can be all individual. They can be programmed as a normally open or normally closed, meaning it doesn't need an end-of-line resistor. They can be programmed requiring an end-of-line, 2K2 end-of-line. They can be programmed for 4-state monitoring. They can be programmed as an analog input. So they're all programmed totally individually on the system. And you'll notice that all the terminal blocks on an M1 are plug-in terminal blocks. So if you want to unplug, you just unplug, and they're all various different sizes. So, for example, the zones have got a different size terminal block than, say, the power output or the relay outputs or the data bus, etc. So if you did have to unplug all the connectors, when you're plugging them back in, you can't accidentally plug in zone into the 12-volt output and cause damage. So that's one of the reasons that they're all different sizes. So the top left is you've got your 16 zones coming down. Moving under that, the bottom left of the clamshell is for our siren, the siren is the 12-volt output. Okay, so you've got, first of all, up the top there, the first pair of outputs. We'll look on the left-hand side. It's 12-volt out, which is switched output. So you can then typically wire that for whatever you want to have that may need to be switched. For example, a latching smoke detector. So you can hard power the smoke detector up from that switched output. So when something occurs, you can get that to turn that power off to that output, the 12-volt output, for 5 seconds. As an example, also, you may want to power your Ethernet module up from that. So from time to time, you may want to reset your Ethernet module. You can wire it into that 12-volt switched output, and then via the keypad, via the app, etc., you can then get that output to switch. Then there's 3 pairs of outputs following under there. Just standard 12-volt output is for connecting to powering up your motion detectors or anything 12 volts continuous output all the time. The last pair of our inputs here is your input for your power supply. It says over here on the right-hand side, AC, DC terminals. We can put AC or DC in there. On the board, it's probably still labelled as AC, 16.5 volt AC. With the new MEPS regulations, it's mainly in Australia, but it's continuing throughout the world, is a standby power supply has to be power efficient. You can't get really easily to get a power efficient AC supply. So we now supply the panel with a DC supply. So we then can put DC in that input or AC. It doesn't matter, etc. Then underneath that input is we've got the power, status, and reverse battery LEDs. So when we've got power on it, the power light will come on. Status light's like a little watchdog. It's flashing all the time at a nice constant rate. And if you did connect the battery, which is shown there, the battery terminal's around the wrong way, the battery reverse LED will come on. Now there's also a switch. That switch down the bottom here will switch both mains and battery. So it's fantastic for when you want to service the system, rather than have to unplug the terminal block to unplug the power supply, disconnect the battery. All you need to do is turn that switch off, and when that switch is turned off, it removes both mains and battery. So you can fully service the system with one power switch. The other thing is, if I want to power the system up, you have to have the mains or AC, DC mains input coming into that terminal. If I just put that switch on and got battery only, it won't power up because in a sense there's no mains coming into the system. But there are some applications where you know there's no mains, maybe because you're testing a system, there's no power onto the premises yet, you want to power it up on battery only. So there's a jumper switch or jumper pads right down the bottom, these 2 little solder pads here. If you then power that up and put a short across those inputs, then hold the short there for a couple of seconds, and you're forcing the system to power up on battery only, not on the mains coming. Because there's had other instances where if it did just power up on battery only, you turn that power switch on and you thought there was mains coming in, but it was never plugged in. If the system powered up, then what happens is after 8 hours or so, battery's going to go flat. You got a service call because you didn't plug the power supply in. So it's another safeguard that when you turn that on, you know that you've got the mains coming in as well. If we now move across the other side of the clamshell, right up the top right-hand corner, so the top left was the of the unit was the zone inputs, bottom left was the power. The top right is where the phone gets connected, your PSTN phone coming. You've got ring and tip, which is your incoming phone line from the telco, comes into ring and tip, and R1 and T1 is your mode 3 socket out to the house premises phone. As more and more fibre or NBN rolls into premises, everyone's losing the PSTN phone line. So what we can do is if you want to dial out on 4G, we've got the 4G dialer that plugs directly into ring and tip, and you get all the functions that you would with the normal PSTN. There's nothing to program in that 4G dialer. You just plug it in, all the phone numbers, etc. program the M1, it will just dial out. Or if you want to have GPRS monitoring back at a control room, like with Permacom, etc., then you can plug the Permacom directly into there as well, and it will then go back. So the Ness 4G dialer will then dial voice dialing. It will go back to a control room with contact ID, or the Permacom will give you IP and 4G back up to a control room only. So you've got both options for when the customer has got NBN installed. Moving down, you can see up the top top right hand side, we've got the dialer we're just talking about. Then we've got the RS232 port that plugs into there. Now that can be used for a variety of reasons. You can plug in a RS232 to USB cable to plug into your laptop or into your computer to program it. You can plug your Ethernet module in there to be able to program or operate the system locally or remote from the Ethernet module. So the RS232 is just a standard null modem 9-pin connection, and that's where that plugs into there. Moving down the board, we've then got in the middle of the board, just under the RS232, we've got 10 outputs here. But let's jump down the very bottom, and we've got output 1, 2, and 3. So output 1, we'll work our way up. So output 1, showing where the black and white wires are connected on the example here, that is for your internal siren. Your inside siren is where the voice comes out of as well. So your typical horn speaker, inside horn, connects in there. You can connect typically up to 6 speakers in there. Once you get above more than 6 internal sirens, then we recommend to go to a amplified voice module anyway. But you can run that down to 4 ohms. So if you put an 8 ohm horn speaker in it, of course you've got 8 ohms. You put 2 in parallel, you get 4 ohms. Put a couple in series in parallel, you can get down to 4 ohm on that input there. So that's where your internal sirens would connect. Output 2 is where it's showing a resistor in there. Output 2 is for your outside sirens. It's a supervised output, so if you're not connecting an outside siren, then you must seal that input up with an end-of-line resistor to have impedance across there. If you're using electronic 12-volt siren output and you've got a high impedance siren and it shows, and the system is showing that you've got a output 2 trouble, that means that output 2, it's not sensing a resistor in there or an impedance into that input. You should really then put something like an 820 ohm resistor at the siren end, because it is supervised. So if someone does cut that input, short that input out, the panel will know about it and say, hey, we've lost the outside siren. Output 3 is 3 terminals on output 3, and it's a dry contact. It's a normally open, normally closed contact, typically for where you connect the strobe into there. So you would connect 12 volts, for example, into the center common, outer normally open, into one side of the positive of the strobe, and negative strobe back to 0 volts. And we can get 0 volts from a number of places. We can get 0 volts, easiest place is up on this connector up here that's showing with this ribbon cable connected, and you can see we've got 12 volts over there. So you can go 12 volts out of there, through common, normally open, through your strobe, back to negative again. So we've got 12 volts there, and then we've also got the other 10 outputs. So you'll notice we've got output 1, output 2, output 3, and then we go output 7 to 16. So output 4, 5, and 6 are non-existent on the M1 panel itself. They're what we call like phantom outputs, and when you put the two-way wireless on, we can use outputs 4, 5, and 6 for programming to do things. Example, we can get the night light on the wireless lux to turn on by turning outputs 4, 5, and 6 on in programming, and the system is smart enough to know, well, when I've turned that output on, we can then turn the LEDs on that night light on the two-way wireless PIRs. So the M1's got outputs 1 to 3, and then 7 to 16 voltage outputs. So those voltage outputs are good for 12 volts, 50 milliamps. If you want to activate something more substantial than 50 milliamps, such as a relay for a door lock or whatever you want to control, then you can plug a ribbon cable into there, get that ribbon cable out of that straight into that relay board we spoke about before. It plugs in, and then we've got outputs 9 to 16. So you've got 8 outputs. So outputs 9 to 16. Outputs 7 and 8 are still visible, are still usable on this relay board. That's done on that blue connector down there. So it's output 7 and 8 on that blue connector, which are still voltage outputs. And then output 9 to 16 are relay outputs when you plug that connector in. If you just want to control 1 or 2 relay outputs for a door strike, you don't want to have to go to a full 8 relay module, then we also sell little single relays. So you can just plug a single relay, for example, straight from output 7 to negative volts, and you can just plug virtually that relay board, just a single one of those relay boards onto the system, or you can plug the 8-way relay board on there. And then the last one down the right-hand side, down the bottom, is a 4-wire data bus that we connect to modules. It's a standard RS485 data bus that goes out. Obviously, it's encrypted, but all the rules of standard RS485 should be followed to make a troublesome-free installation. And when we do that, when we run a 485, it should really be daisy-chained when we wire a 485, not home run, but we'll have a look at this in more details. With the M1, we should ideally, in an ideal world, which there's not always an ideal world, we come out of an M1, go to the first module, the next module, the next module, the next module, etc. So we've got a definite start and end of the 485 data bus. And what we should do is terminate with an end-of-line resistor at each end, the furthest end. In this case, it's at the panel and the output expander. Doesn't mean you've got to then connect a resistor across in with the wires. The panel has got, or the modules have a end-of-line resistor built in. So all you need to do is put the link on. So in the M1, we put the link on the termination here to add the end-of-line resistor for that end. No link, no link, no link. And the one at the very end, we put the link in here to terminate that end-of-line. Now we've got that 485. It's balanced to both ends. Nice trouble-free installation. If I was to terminate all of them, then it's going to really throw the 485 out and we're going to cause issues. If you want to home run devices, then we've got 2 different type of data bus hubs that we'll have a look at shortly. We've got the DBH and the DBHR. This one will cater everything in and out for you, so it'll go in and out, in and out, in and out. So it goes in on 1, out on 2, 3, 4, 5, etc. And this gives you an additional 4 branches that we'll have a look at. So on this example here, as I said, you have to terminate your 485 data bus at each end. So on this example, where we've got the main panel and we've got 2 keypads, what I would do is terminate JP3, put the link on there and the link on the last one on the bus. So we've got the first and the last. When we daisy chaining here, we've got 2 home runs going to the panel. So in this case, the panel is effectively in the middle. It's like in the middle. So we're coming in and out. So there's the first, there's the start, and there's the end, or there's the start. So they're the 2 furthest ends labelled with C and F. So in this instance, we'd put the termination in C and F, not in the panel because it's not at the end. And we go in there nice and simple. When we want a home run, we've now introduced the DBHR. The DBHR, it's a RJ45. It needs at least 6 wires connected into it, typically used for a Cat5 cable. So when we've home run all the modules back in, it's still going to go in and out to each module, but this module will arrange it for you. So we'll go in, out, etc. So in all this example, what we would do, we'd put the start of the line on A, it comes through, out on 1, back in 2, and 3 and 4, and then we put the RJ45 with the end of line resistor clip in there as the first and the end of the line coming through. If we haven't run the cable in Cat5 where you've got a 6-core, you've run it in 4-core data cable, or alternatively it's a retrofit system, so they've only got 4-core alarm cable perhaps for the home run devices. We've got the DBHR, so where we had one branch of RS485 on the main panel, when we introduce this, it gives us 4 branches of RS485. Same rules follow. We've got 4 end-of-line resistors for the 4 branches, or 4 links for the 4 branches. So we'd follow the same rules. So let's look at the first one over here on A and B. So when we look up here, we terminate on A and terminate on B, which terminating that 485 branch. Then we've got the other 485 here. On this example, we have 2 keypads. So we terminate at the start of the run, and there's the link for that branch there. Branch B, we've got a keypad and expander, so we terminate at the start of the run and the end of the branch. Again, that we don't have the end of line in this here because it's not the end, it's the start and the end. Our third branch, on this example, we've got an expander, another expander and a keypad. So again, we don't terminate at this module here. It's at the start and at the end. And on this branch, we've got one expander on there. So we put the link at the start and at the end. If you follow those rules, then you'll have no issues with data bus cabling, etc. When you put that the link on, what it's effectively doing, it's adding 120 ohm end-of-line resistor in. So at any time you think you've got a trouble with the data bus, something's not quite working properly, if you rang our tech support, the very first thing they do is tell us to power the whole system down, mains and battery, and put a resistance meter across A and B at each branch, and you should ideally measure 60 ohm, give or take a few ohm for cable resistance. If you're measuring open circuit, it means you've got no end-of-line resistors at all in that branch, so it's measuring open. If you're measuring 120 ohm, then you might have your end of line on one end and not the other because you've only put 120 ohm in. Add another one in, so you've got 120 ohm and 120 ohm. In parallel, it drops it down to 60 ohm. And if you're measuring 30 ohm or something low like that, then what's happened is you've got an end-of-line resistor in all of them. So therefore, you've got 120 in parallel, 120 in parallel, 120. So you've got 120 down to 60, down to 30, and so on. You've got it's showing you straight away what the issue is. So it's critical to be able to do it. The other handy little hint, the DBHR module should be wired near the main panel. It's advisable not to wire that DBHR module out in the field and running that cable, etc. It can be done, but it can cause issues as well. So wherever possible, mount the data bus module, the hubs, in with the main panel. When we program, we've added the modules onto the bus, we have to then address them. The modules are broken into 4 different types. Type 1 is a keypad, so whether it be an LCD, navigator, touchscreen, etc., or single door access module. The single door access module is treated as a keypad, and there's various reasons for that I won't get into here. But if you treat it as a input, like when you badge a card at the reader, it can input like you're inputting a code into a keypad. So it's classified as type 1. Type 2 is a zone expander, whether it be hardwire or wireless. So type 2 is an input expander or a wireless receiver. Type 3 is your output expander, and type 4 is your serial port expander. Now, the reason we break them into various types is so we can get the number of modules on there, and so the system knows the protocols coming in, what type they are. So on a particular M1 system, I can have, for example, a keypad at address 2, an input expander at address 2, an output expander at address 2, and a serial port expander at address 2, because they're all different types of modules and types of protocols coming in. They'll work happily on the system at once. But I can't put 2 keypads at address 2 because they'll clash with each other because they're the same type. I can't put 2 zone expanders on the system at address 2, again, because then we'll end up with 2 zones being the same. It will clash. Same with outputs and serial port expanders. So as long as they're on different types, they can be the same address, but you can't have the same address on 2 different types of modules. When we add modules to the bus, each one has to have a different address, as I mentioned. Keypads have to start at address 1. I have to have a keypad at address 1 all the time, and then the next keypad will be address 2, 3, 4 onwards. If I start my keypads at address number 2, the system's going to say we've lost keypad at address 1. So you always got to have one keypad at address 1 up to 16. On the expander modules, we have to start at address 2. We can't have a zone expander at address 1 because we've already got virtually a zone expander or an expansion module on the main M1. So therefore, when we add that expander has to start at address 2 onwards. The same with output expanders. The output expander have got to be address 2 onwards because effectively we've got our first expander built into the main board. So expanders are on 2 onwards, keypads at address 1 onwards because there's no keypad on the main board. Address 1 on keypad is enrolled in the system all the time, so you can then get into program. As soon as you've got a keypad on there at address 1, power it up, it learns itself in, and it's built into there. Keypads at address 2 onwards will not work until we go into the system and say, go and enroll the modules on the bus. Same as the expanders. Expansions modules 2 onwards will not pick a zone up or won't not work on the system until you tell the system, go out and add those systems to the bus. To address the modules on the bus, the LCD keypad, you push and hold the star button for 15 seconds. So you power the system up, push and hold the star button for 15 seconds, and then on the display, it will then say, use the up and down arrows to change the address, push exit when done. So then I use the up and down arrows to go to address 2, 3, 4, or whatever you want, hit the exit button to save it, and then that keypad is now set for that address. The navigator keypad's slightly different. When you first power the navigator keypad up, there'll be, for about 5 seconds, will flash on the screen, a button that comes up on there that will tell you to change the address. And you push that button, they'll all be set for address 1 out of the factory. You set the next keypad to address 2, then the next one at 3, 4, 5, etc., till you address the keypads to the ones you want. With the expansion modules, input and output expanders, they have dip switches on them to set the address. It's done in binary, so you put 1 on for address 1, 2 on for address 2, 1 and 2 on for address 3, and so on. So in this example here, little handy hint, don't look at the numbers that are on the switch themselves because that's just a generic switch we use on the modules. But on the circuit board should be silk screen 1, 2, 4, 8. So you follow that to add them. So you put 1 on for 1, 2 on for 2, 2 and 1 for 3. So on this example here, we've got 8 on, plus 2 on, plus 1 on. It's address number 11. Okay, so we've got one switch 1, 2, and 8 on is address number 11. So it just adds it up like that. And also in the manual, it does show you a guide if you can't count. So when we set the address on, for example, an input expander, the address will then set what zone it is. So the main board, which is effectively address number 1, is for zones 1 to 16. If I had a zone expander at address number 3, so we've got 2 on plus 1 on is address 3, it zones 33 and 48 in programming. If it was an output expander at address 3, again, it's output 33 to output 48. So we can build up right down to 208 inputs and 208 outputs. It's not really a true 208 outputs because keeping in mind that outputs 4, 5 and 6 on the main panel aren't there, so it drops it down to 205. In a roundabout way, we can add something to get it back to 208. We've never had to yet, but that's how we know by what the address of the module is when we're programming it. I want to switch output number 97 on. We know what output that's going to be on that particular module when programming. So once we've added the module on the bus, we've wired it properly, we've added the correct end-of-line resistors for the start and the end of the bus, we've set the dip switches or addressed them correctly, we now have to tell the M1 to go and poll your data bus and add the modules onto the bus. To do that, we do it in program mode via the keypad, or we can do it from the programming software, LKP software. To do it on the keypad, we just simply hit the menu button. We then go across to install the programming, and the very first option, install the program, is bus module enrollment. So when we press menu, we go across to installation programming. It will ask us for the installation code. You have to know what the installer code is, and as default it's 172839. And how am I going to remember that? It's 172839. Top, bottom, top, bottom, top, bottom. It will then take you to install program mode, and the very first option, as I mentioned, is bus module enrollment. When I push bus module enrollment, all the modules, including keypad address 1, will drop offline, get unenrolled, and then they go in and get enrolled, scans the bus, and will add all the modules it's found on the bus at that time. And it will then come back and tell us how many bus modules it's found. We can then go and search and view the number of bus modules it found, see what they are. In case you had 8 modules and it only found 7, you can go and see which ones it's missing, go back to the one that's missing. Oops, I forgot to plug the connector in, plug it in, and then you do another bus module enrollment, and it'll add the ones that you've done. If for some reason you need to take a module off the bus, perhaps you added another zone expander too many and realised you didn't need it, or an output expander. If you just unplug the module from the bus once it's been enrolled, it will come up as an alert to say we've lost a bus module. To take it off the module, you then unplug it and then do another bus module enrollment. It will then take them all out and re-enroll them, the ones that it finds on the bus at that time. That's how you take it off the bus once it has been enrolled. We'll now have a look at the operation of the system, the keypads, what all the buttons mean, what we do. Is there any questions up until this point of what modules can go on the bus, how to do the bus module, how to enroll it, how to address it, or anything like that? No, everyone's good, no questions? All right, so we'll have a look now at the operation of the system. Operation, whether you're using an LCD keypad or whether you're using a navigator, we find we sell a lot more navigator keypads now, but the operation is identical. So when we arm or disarm the system, in arm mode, we can arm it into 2 different modes. We can arm it in away mode or vacation mode. When we've armed it in away mode, every zone is armed. That belongs to that area, and obviously disarm the same. When we arm it in vacation mode, it still arms every zone the same as you would arm it in away mode, but via programming we can then add some more module or more rules or features when we've armed it in vacation mode. So as an example, when I'm leaving for work or the last person out, can arm the panel, come home, disarm it, and we'd normally just arm it in away mode. Maybe when you're going away for extended periods of times, you're going on vacation or whatever you may want to do, we can then tell the M1 when the panel is armed in vacation mode, then do something special. So for example, we might say when we've armed in vacation mode, turn lights on and off randomly at night time so it makes it look like somebody's home. It won't do that in normal away mode, but it can do it in vacation mode. You might also say when the panel is armed in vacation mode, activate some outputs to perhaps turn the fridge off, the freezer off, etc., because I don't want those running while I'm away. So just by arming a vacation mode, bang, it will instantly do it. You don't have to do anything else. When we armed in stay mode, there's 4 different functions when we armed it in stay mode. Stay is like where you want to arm it, and it depends what school you went to, what terminology you want to use. Stay mode, home mode, monitor mode are all various modes. So I want to arm it, but I'm staying home. I'm not going to leave. So I want to arm it and leave the perimeter on. So we can arm it in a couple of different modes. Obviously, armed away will arm all the zones. Stay mode as an example. Let's look at just stay and night for the moment. Stay mode will arm perhaps the perimeter, all the doors and windows, but turn the PIRs off. So I'm downstairs watching TV. I've armed it into stay mode. I can freely move around inside the house. The PIRs aren't going to detect me because I'm home. I then want to go to bed, and I can arm it in night mode. So when I go to bed, perhaps upstairs, we arm night mode, which keeps the downstairs perimeter on, all the doors and windows on. But now we've added the PIRs downstairs on, and we've still got, in night mode, we've got the upstairs PIRs turned off while I'm sleeping upstairs. So as well as the perimeter on, we've added another group of detectors, if you will. Okay, so if we're looking at it, armed away is arming everything. Stay, we're just armed perhaps the perimeter. Night, we've armed the perimeter and added some PIRs. We've then got stay instant and night instant. When we're in stay mode and we've got the perimeter PIRs, doors and windows on, your typical front door is still an entry-exit delay. Someone opens the front door, it gives you a delay time to get to the keypad to be able to turn the system off. If we arm it in stay instant mode, that entry-exit zone, let's say typically your front door, becomes an instant zone. So as soon as we open the front door when stay instant, when we've programmed it to go into stay instant mode, we open the front door, we do no longer have a delay time, it will go into alarm straight away. The same if I was arming night instant. I've got night instant on, so I've got downstairs perimeter on, perhaps downstairs PIRs on now while I'm sleeping upstairs. Again, as soon as you open the door, the front door, it's going to go off instantly. Doesn't give us time to get to the keypad, which may be fine because we're already home, etc. So that's where we can armed in night instant mode. Okay, so they're the various modes. Arm away will arm everything. Vacation will arm everything, but can add some other functions to do things when we're armed. Stay mode will have perhaps the downstairs perimeter on or the perimeter on. Stay instant will have the perimeter on, but the delay zones are now in instant zone. Night can have the perimeter on and downstairs PIRs, but we've still got a delay at the front door. And night instance, downstairs PIRs on, for example, PIRs, and we don't get a delay on that front door. Now, how we get ARM into those various modes is we've got an exit button and a stay button. Okay, now, as default out of the factory, we do have quick ARM, so I can just hit the exit button and it will automatically ARM in away mode. The problem with that, though, is that when we want to force arm a zone, for example, if I've got a PIR looking at the keypad, maybe the front door's armed, when we're arming the system, it's very annoying if you had to tell the customer, stand still so the PIR that's looking at the keypad's not detecting you while you hit the arm button, because I want to force arm, because if there's a zone unsealed, and even if it was programmed as a forced arm zone, when I hit exit, the system's going to tell me that we've got a forced arm zone that's unsealed at that time. Are you sure you want to arm the panel? And if you say, yes, I'm sure, it will say, well, enter your PIN code to verify that you really want to arm it. So if you've got to then add a PIN code, enter your code, then what my recommendations are is that disable the quick arm, disable that exit button quick arm, and then just enter your code to arm anyway. So if it's set for a forced arm zone, and it's not set for quick arm, I just simply walk up to the keypad, enter my code, for example, 1234, If that zone is unsealed, it's going to arm anyway because it knows I've entered a PIN code to verify that I want to arm with that zone unsealed. Okay, so to arm it in away mode, recommend just go up, enter your code. 1234, for example, will arm the code. Come home, 1234 disarms it. You don't have to enter any button before. You don't have to hit arm, then your code, and then enter or anything like that. It's just enter your code, will arm, enter your code, will disarm, will toggle it to the opposite state that you're in. If I want to arm in vacation mode, then I've got to go one step more than arming away. So what I would then do is I would arm the panel, for example, 1234, the panel will now be armed, and then during the exit time, I hit the exit button. So we've virtually armed it, and then we've exited again, like we want to arm it to a higher level. We'll then take it from arm away to arm vacation. So when I push 1234, you'll hear the speaker say system arm to away mode, and then when I hit the exit button, it will say system arm vacation mode. Okay, so we've gone to that higher level. Same in stay mode. So when I go into stay mode, I enter my code 1234. We've armed the panel, but now I push the stay button, which then will say system armed in stay mode. Press the stay button again, system armed stay instant. Hit the stay button again, system armed in night mode. Hit the stay button again, system arm in night instant. Toggles between the various stay modes there. That's if all of them are enabled. If the customer only ever wants to use perhaps stay instant, that's the only one that they use. Via programming, we can only enable stay instant and disable the other three. So therefore, when the customer wants to have it, the perimeter on while they're watching TV but wants to have it instant, all they do is push the code and push the stay button, and you don't have to cycle through. It's only going to go to the one that's enabled. You only have to cycle through if when it's programmed if there's more than one option selected. Okay, so just recapping again, arm away, just enter my code. Arm to vacation, enter my code to arm the panel, then push the exit, puts it in vacation mode. Stay mode is enter my code and tell it I want to stay, and then push the stay button, stay button, stay button to get to the mode of stay that you want to get to. Okay, so that's what the stay and exit buttons do. To disarm the system, you'll always have to enter a code, whether it be set for 4-digit or 6-digit code. So the system will be armed. When you come into the premises, you have to enter your valid 4-digit or 6-digit code, depending how the system's set up. Of course, if you've got a card reader